In this video, I will create an example of overloading a function, and that means that we will have two functions with exactly the same name. So the second function would be the overloaded version of the first function, right? And then we will see how we can use overloaded functions in some situation. Okay, so we put a comment here, example of using overloaded function. Okay, so can't include. So here we have an example where we have two functions with the same name called calc amount. In one case, the function will be able to apply the discount percentage because we'll be sending the discount percentage to that function. In the other case, the function will not be applying any discount percentage because we will not send any discount percentage. Okay, so I will create a few variables here. So int quantity double price and discount percentage. Okay, so it's price and discount percentage. Now here first we get this information from the user. So cout please enter the quantity cout price. Right. Now we need to get from the user whether or not there's any discount on this item. So we need a char variable. So I'll make a new char variable here, char yes no, and we will take the user response yes or no and put that in. Yes no. So I'm going to put this in a user input validation loop. So while we come back here, so cout does this item get a discount? Okay. Then the user tells us yes or no. Put the response in yes no. Convert yes no to uppercase. Okay. So here we go. So does this item get a discount? Put that in yes no. Then convert yes no to uppercase. So then our test is as long as yes no is not uppercase y and yes no is not uppercase n. Okay, so if the user gives us anything other than y or n, meaning it doesn't give us y and it doesn't give us n, so that's a mistake. So the user will stay trapped until he gives us either a y or n. Okay, at that point he'll be outside the loops, and then we can test what he gave us. So if you say yes no equal uppercase y, right? There's no upper lowercase yes no no. In that case, what we do is we get the user to tell us what is the discount percentage. So we write cout please enter the discount percentage in percent, like not decimal. Then we put that in discount percentage. Okay. Then we make a function call to the function calc amount, and we pass the three pieces of information that we have. So we go calc amount, and we first pass the quantity, then we pass the price, then we pass discount percentage. Okay. Now you can right away see that Function call is not part of an assignment statement, meaning there's no assignment operator, there's no variable on the left side of the assignment operator. So that should tell you right away that this function does not return anything back. This function simply does its job and shuts down, and the control is sent back to the line following the function call, okay, which will be this curly brace right here. So you can just look at a function call and actually determine whether or not this function returns a value, because if this function returned a value back, there will be an assignment operator to the left of the function call, and to the left of the assignment operator would be another variable that will receive the incoming value. So else would obviously be n, because we don't allow anything else, so we write else. And here we don't have to ask for any discount percentage, because in this case the user says this item does not get a discount. So we just make a function call. So I'm just going to copy this function call and paste it here. Okay, so Control C. We make the function call to the overloaded version of the function calc amount that has no parameter for discount percentage. Okay, so we have two versions of the function calc amount. One will be with 3 parameters, with quantity, price, and discount percentage, and the overloaded version, the second calc amount, would be not be having any discount percentage, so their signatures are different. Okay, so the compiler will be able to differentiate or distinguish between the two overloaded versions of calc amount by simply looking at the parameter list. In one case there is int, double, and this one is int and double, right? So they are different signatures, so compiler can determine very easily they are different functions. Okay, now once we are done with this, that's pretty much all there is. And now what we can do is we can simply, because the function returns nothing back, we're done with the main function. Now we write the calc amount, which is void. But this one, as you can see, so this is the original version, so we'll write, it has 3 parameters: int quantity, right? So int q, then we have double p, and we have double d, okay, for discount percentage, right? So in this version we create a local variable here, double amount, right? So we write amount equals quantity times price, right? So this is the whatever quantity you bought multiplied by the price of each item, minus, in this case, subtract the discount. That would be q percentage q star p star d, or discount percentage, by 100. Why? Because we got the discount percentage as a percentage, not a decimal. We must convert it to decimal, right? So this is the original amount, quantity times price, and this is the discount part, which is quantity times price times discount percentage. Okay, a certain percentage of the original amount. So this is the discount. If we subtract the discount, we never add the discount. Okay, then we can simply see out the amount after discount is dollar symbol. Okay, there you go. So this is the first version of calc amount. Now we write the overloaded version. Okay, the overloaded version of function calc amount doesn't have any discount percentage, so the signature would be different, right? So we write void calc amount. So this would be int q double p. That's it. There's no d. Okay, so because there's no discount in this case, and I'll just copy this one here. Just copy all of this and have to type all over again. Put this here. Because there's no discount, I'm just gonna remove this part. That's all we have to do. And since there's no discount, we remove this message. Okay, all right. So this is the overloaded version of the same function calc amount. So the signature of this function, as you can see, is calc amount int double. The signature of this function is calc amount int double. So the signatures are different. So the compiler has no problem allowing these two functions to exist in the same program, because the compiler can very easily differentiate between the two functions. Okay, so you can ask, how does the compiler know which function to go to? For example, we call calc amount with three arguments, excuse me. You call calc amount with two arguments right here, as you can see, two arguments. So the compiler selects the function to go to by looking at the signature. So in this case, as you can see, it says we are sending, in this case, three arguments. So obviously the function to use is the one with three parameters. Okay, if there were same number of parameters, then it will be decided by the data types of the arguments. So if this was int, this is double, it will obviously pick one with int and double. So int double double, it will pick one with int double double, right? So the compiler selects what function to use when you pass an argument by either looking at the number of arguments you're sending or by matching the data types of the arguments with the data types of the parameters. And if they match up, the compiler will use that version of the function, because there are multiple versions. Compiler has to decide which one to use. So it's either the number of arguments that match the number of parameters. So it's easy in this case. If they're the same number in both cases, both the versions of the function, then it will be the data types of the arguments will be matched with the data types of the parameters. Okay, so now we must overload, or we must prototype both the versions. Okay, so you have to override each version separately. So I'll take this one first, go above id main right here and write it like this. Now when you write a prototype, what happens is you don't really have to put the parameter names. So I can actually remove the parameter names, because the compiler doesn't need them actually. Okay, so even if I remove the parameter names, it is just fine. So prototyping, you have a choice. You don't have to. I normally don't bother, but if you are kind of a person who would like to do this, so it would be, you can remove the parameter names from the prototype only, nowhere else, right? You need them in the main function, so in the function that you call. Okay, so here I can actually remove the parameter names. We don't need them when we make prototypes. So the prototype only needs return type, identifier, and the data types of the parameters. It really doesn't need the names of the parameters. So if you remove the names of the parameters, you're equally fine. There will be no problem with your program. Okay? So the program appears to be complete, and we can try and build this program, right? So I'm going to call this one overloaded function example.cpp. Okay? Overloaded function example cpp. And we have an error. It says calc amount quantity comma price, and let's see what that error is. I can actually look at the comment. It says let's see what's going on here. On line number 29, it tells me expected closing. Oh, I actually put parentheses instead of curly braces. My bad. Okay, so that should fix it. Okay, so this time the program compiles, and we can put in the quantity. So we put the quantity 1000, okay, hit enter, then put the price as 15.25, okay, because the price is a double. Then does this item get a discount? We should actually put a y in there, so I'll change the program a little bit. So let's say I put a lowercase y, that will be converted to uppercase y, and I say yes, it gets a discount. So now it's asking me what is the discount percentage. So I'm going to put the discount percentage as 15%. We get a 15% discount, and it shows me that the price after the discount, sorry, there's a typo there, is 12,962.5. Appears to be good, right? So now we can run it again. This time I will say there is no discount. So let's put the same quantity, 15.25, they get a discount? No, it doesn't get a discount. And it picks the version of the function that has no parameter for discount, simply does the calculation, right, and shuts down. So in the first case right here, when we call this function, when we make this function call, the control of the program jumps from the main function that is put on the hold, and the compiler selects the correct version of the calc amount that it should use, which is this one, and this one has the matching parameters, right? If we're sending 3 arguments, it picks the one with 3 parameters, applies the discount, and displays the discount. Okay? In the second case, when we make this function call here, where there's no discount, right? Calc amount, this is a function call, right? So in the first case, after this function is done, the control will jump back to this closing curly brace, else will not apply, because else is not applicable in this case. It will go to return 0 and end. In the second case, because we said no, else kicks in, not the yes, no, equal y. So this function call is made. So the control of the program jumps from this line, the main function is put on hold, and the compiler automatically selects the function with the proper parameters. So we're sending 2 arguments, it selects the function with 2 parameters. So it uses this function, finds the amount, displays the amount, and at this line the control comes back to this closing curly brace, and then return 0 and the program ends, right? So overloading functions is very, very common. In fact, many languages, for example, C#, even C++, provide inbuilt functions which are overloaded numerous times. So overloading is a very popular programming concept. So you will find multiple versions of the same function, each one differentiated from the other by simply the signature, which is the name of the function and the data types of the parameters. Okay, so this is a small and brief example, and it's very similar to the problem that we have in the assignment number 12. So if you watch this video, you should have no problem solving the similar problem we have in the assignment number